Welcome to SendCutSend.
Thank you.
So this room is kind of a hodgepodge. This is R&D. This is non-metals. This is where we experiment with new materials. This is where we experiment with new processes. Because we have multiple locations, if we have kind of a weird piece of equipment that we make modifications to, it comes here first.
Okay.
And then we replace the boards or do wiring harnesses or make modifications before it ships out to another facility.
But if you're gonna get into welding or something like that, that probably starts
I can't show you that super secret room over there.
Okay.
You guys could. But yeah.
It's just a guess. Yeah. Okay. And so
Here, I'll walk you through experimental laser, water jets. So our water jets, they cut anything that a laser can't. So for those materials like rubber and neoprene and gasket materials and stuff, then we'll use water jets. So anyway, all kinds of, this is like our secret workshop. If we're testing something new in here, oftentimes you'll smell it because we have the air quality wrong or the cutting speed's wrong or whatever. But yeah, this is probably my favorite room because it's always changing. There's always new cool shit.
something new is taking place. Yeah. Cool.
Lasers do a great job. Water jets do a great job. Sometimes a CNC router is going to do the best job. Supplies. Raw materials.
What do we have?
A little bit of everything. This is mild steel, aluminum, some stainless steel. We call these bricks. And this is where, if it's a heavy moving material, then we'll just leave it on a brick because we can move the sheets really rapidly with our section equipment.
Okay.
We try and carry 2 weeks of material at a time, but mostly because we're square footage constrained. So we're doing some maintenance on air compression. Air compression is like the heartbeat of this place.
Yeah.
But yeah, raw materials come in, they're stored, but they're always moving. So the height of these bricks tells me like how busy we are.
Okay.
And so there's kind of like a known, I know right at my belt if that's, a really busy day or not.
So where are we now?
Right now I feel very comfortable.
Okay.
Like we can handle a few spikes.
Yeah.
Because we're on demand and quick turn, you don't just have enough material to get you through that week. You have to have enough material to get you through that week, plus an emergency order, plus a spike, plus like what if there's a snowstorm and the truck can't get over the hill or whatever. So when it gets down to my knee, I start to panic a little bit.
Me is the panic zone.
Yeah, but right now I feel pretty good. We can make just about anything you want.
Okay.
So careful of this. This is a new machine that we're provisioning. This is like the prettiest machine to film because it hasn't been running yet. This is a 12 kilowatt fiber laser. And it's all magnetic drive. There's no ball screws or anything. It all moves on magnets really rapidly. That's why if you have a pacemaker, you can't stand near it.
Shit, dude, you didn't tell me that.
Yeah, sorry. But yeah, this is the newest in the fleet, best of the best. But this came from years of refinement and understanding what works and what doesn't.
How much does this cost?
This is 1.2, 1.3 million.
And who makes it?
Amada.
And are they German, Japanese?
They're a Japanese company.
Yeah.
But they manufacture in Brea, California, and High Point, North Carolina.
Oh, okay.
Yeah.
Okay. And then, so as far as like the heart of what you guys do, I mean, is this building close to sort of center of gravity, or you can't really pinpoint it like that?
Yeah. I guess so.
Yeah.
I mean, this is where a lot of the innovation is happening. This is where we're doing all the experimenting and stuff like that. But our goal is to have each facility almost identical. They should all be interchangeable. We just burden this facility with all the bullshit before the other ones. Like, I want to make sure that if Kentucky gets a machine or if Kentucky gets a process, it's fully vetted so that, I just don't hand them a box of shit and be like, I hope it works.
Yeah.
That's why we force ourselves to deal with all this.
Well, what kind of parts would come out of here? I know it could be anything, but just, I don't know, to give people a feel for the range.
Anything. Something from like a little bracket and a washer to like an ultra complex jig that's going to help someone do fixture welding on a rocket motor, or, you know, I don't know.
Could be anything.
Yeah.
Yeah.
I haven't thought about that question because it's anything.
And
I'll show you. You'll see.
You'd take a sheet of metal into here.
Yeah. So they have this here. Let's show you another one. Just watch it. Don't put your feet under that. So this is a machine that's been in use. You see the slat table gets a little more beat up. We actually manufacture the slats in house.
Okay. Oh, cool, man.
The laser will eat them away over time. So you load material on here, and then these tables slide in. There's 2 tables, and they can pass above each other. So there's always something in the machine cutting. So we target, between 80 and 90% machine utilization. So we want these yellow lights. The yellow lights mean we're making money.
Okay.
So it's good to see 4 yellow lights, soon 5 yellow lights here.
And would this go 24/7?
Oh yeah.
Yeah. How many? 3 shifts?
We run 4 shifts.
4 shifts.
Yeah, we run a set of 10-hour shifts, so 4 10s with overtime, and then we run 3 12s. So Friday, Saturday, Sunday are 12.
Okay. And how close would this be to the original machine you bought?
This is the Cadillac.
Yeah.
Actually, this is like the Veyron. The original machine was still an Amada, but it was only 3 kilowatt, and that's kind of how the pricing goes. It's every 3 kilowatts is like $200,000. So you can buy a 3, a 6, a 9, a 12. We standardized on the 12 because they're just so damn fast.
Yeah.
It's speed. We're square footage constrained, so if I can have double the output in the same square footage, then that's why we upgrade the machine.
Okay. And I know some parts in here are top secret. Are we allowed to peek at what these guys are doing? Or?
Yeah. What's up, gentlemen? How are you? So, yeah, we should. Yeah, that's.
Okay. They're friends. We can probably talk about
Don't
that.
show the paper too much. These guys are cool. These parts came off the machine, but they have to be separated. So, what we're seeing right here. This little bit, yeah, it has to be punched out. Sometimes it just comes out by hands, or it's a little better if you use a tool. Some of them fall out, some of them don't fall out. So, manual. People are like, "You need humanoids," and they're like, "No, just you need dudes." So our dudes are great, and our dudettes. We don't have any dudettes over here today. Anyway, everything is sorted and associated with an order. This is the machine cutting.
Oh, shit. And like we talked about before, I mean, the goal is arrange as much stuff as possible on this one sheet so that you get as many things out of it as you can.
Yeah, here, you can come film on the side too. Good look in there, check it out.
All right, super cool, man.
And this is the material that we're cutting. This is brass. These are thick brass.
Yeah. How long would it take? I mean, it looks like it's going pretty quick. How long to etch something like this size? I mean, it's doing it right now. So
3 seconds?
yeah.
So like on the water jet, this would be minutes.
Yeah.
Here, it's seconds. What you're doing, you're taking 12 kilowatts of power, focusing it down to something that's smaller than a period at the end of a sentence.
Yeah.
And so it's like multiple households worth of power on this little point that it vaporizes the material. And so then the sound that you're hearing is nitrogen. We're using liquid nitrogen that becomes gaseous nitrogen to blow that vaporized metal out of the way before it re-solidifies.
Okay.
You don't blow it out of the way, it just welds back together. So I'll show you where liquid
So
nitrogen.
you need electricity, you need nitrogen, what other raw
Air,
materials?
phase, dust collection.
Yeah.
These really small parts, they're getting cut out of the big piece, but sometimes they fall all the way through the machine. So this is where little stuff comes out.
So there's like a little conveyor in the machine?
Yeah, there's a conveyor this way and then a conveyor this way.
Okay.
So and then you also get our weight. This is just solidified metal dust. just waste,
Yeah.
slugs, and whatever. But if part of it is a treasure hunt. Customer orders 1,000 or something and they're little.
Yeah.
We have to make more than 1,000.
Okay.
Yeah, they get lost in the belly of the beast.
Okay. And this thing like runs 24/7. Like how often does it go down for maintenance or?
There's daily maintenance, there's a weekly, and there's a monthly.
Okay.
So we stagger each machine is on a schedule.
Yeah.
When it's going to go down. We have a strike team that comes in and does like a deep clean and whatever. Like, okay, we're going to do that on Monday night and this one on Tuesday night, whatever. So we can always have maximum production.
Yeah. Okay.
Then this represents a few days of waste. There's a mix. There's some like good usage areas on some of these. Just depends. We have rules where if a remnant gets too small, it's actually faster and cheaper for us to grab a whole brand new sheet.
What's the remnant?
Remnant is when we didn't use an entire sheet.
Okay.
So there's a rem, if it's usable stuff that we'll use, or we can reuse until it's gone. But if it hits a certain size or if it's a time of day, it depends on what the algorithm says. Sorry, that's our dust collector. So one of our dust collectors. If the rem gets too small, then we just scrap it because we found that the labor of like tracking the remnants and all this, it does for the actual stage.
Okay.
So aluminum, steel. So you can see like we get a lot of usage out of our stuff. Our nests are pretty lightweight. These are some parts that didn't make QC. They've been bent, like they went through bending, but they failed for whatever reason. So
And the dust collectors, they're attached to the machine and they're just hoovering off the particles coming out all the time.
So all those particles that we're making, we're trying to suck it out of the building, air quality, and then it gets collected in totes and then disposed.
Okay.
So here, we'll go to the next step. So yeah, we have material loaded. So as soon as this one is done cutting, then it's going to cut copper. When this one is done cutting, then it's going to cut this material. So there's always stuff moving in here. One of the things that I look at, I'm always looking for a naked shuttle table. These are called shuttle tables. If they're naked, like that one doesn't have any material on it, it means we could potentially run out of work for that machine. So there's always guys going and receiving new material, putting the material.
So what's he's getting like a new sheet right there?
Yeah, so he's calling for a new sheet. So the scheduling system said, hey, you have 20 minutes left on this sheet. The next thing that we need to cut is on shelf number 7. Go pull it, load it.
It's kind of overwhelming, man.
There's a lot going on.
Yeah.
So after it's been cut and passed our initial quality check, because as the guys are taking stuff off the laser, they're looking for quality. They're looking for edge quality, cut quality, correct count, everything else. Then it gets into a tote, and then it gets associated with a barcode. And then from there, it's just scan the barcode and do what the barcode tells you.
Okay. So. And when, there's these steps. Sometimes in these other factories, it's like they want all this automated. They don't, you guys actually see humans here. Yeah, you find it's like, just makes a lot of sense to have a human take one thing and put it in here.
We are a software company at our core. All of our team is super into robotics and, cutting edge technology. We know when to use it and when not to. We're getting there. We're automating more and more of that process, but I think there's a lot of like, oh man, if I automate everything, I'm going to have this like huge win. Like, no, just start and use guys to get going. And then after you have enough guys, you can figure out like, oh wait, this system would help out really well over here, or this robot. For example, we got a quote to move all these totes through the factory. It was $4 million of conveyance. I was like, well, what happens if I need to change my route? And they're like, oh, we'll work with you and we'll re-quote it by $1 million every time you change conveyance. Well, we figured out it's just like a guy, on a golf cart can have all the flexibility in the world for, not anywhere near $4 million. And he can still answer the door and greet a customer. He can push a broom or he can load material or whatever. So someday we'll have more automation, but we'll be the first ones to use it. So if we're not using it, it means that we tried it in a different.
Not ready. Yeah. Okay.
So yeah, this is our solution to $4 million of conveyance. We got this on Facebook Marketplace during one of my like late night just scrolls. So this came from like an airport or something. We built these.
Yeah.
But this can drive around the whole factory, pick up in any order that's needed. You know, so we call it the train. The train has a bunch of different stops. You know, like a postal carrier.
Yeah.
So they go around, they pick up from the lasers, drive around, and then they'll start dropping off in second ops.
It's just got a human vision system instead of a computer vision.
Very advanced human vision system. And I'm not shitting on automation. Like, if we made the same part over and over, like I would automate this place to heartbeat. But when you're doing high mix, low volume, like all of our parts are wildly different, and they all have different order of operations. There's so much variance. A lot of people who have never done manufacturing are like, manufacturing needs to be automated. I'm like, come work here for a little bit, and then you'll see that you're wrong.
Reality.
Yes, there's a lot of opportunity for automation, but people just go nuts. And sometimes you just have to do the basics really well first.
I like how you guys do everything step by step anyway.
Yeah. So the metal right off the machine often needs the second operation. So that's what you're seeing here. You're seeing deburring, tapping, countersinking, you know, things that customers need for their final assembly. So we use a variety of different deburring machines in order to smooth out the part a little bit. Let's see if we have an example. Like these. Not really supposed to touch these without gloves, but right off the machine, it's a little bit sharp on the edges. It can have scratches or whatever. So in order to remove that for the customer, then they send it through one of these machines.
Okay.
Strip everything off. Or to prep it for the next process, like these are actually going to get powder coated. So it's a prep operation for powder coating.
And how do they know when this is done? I mean, it says 4 items. Somebody just comes and checks if there's 4 in there, then they...
So the initial schedule said 4. When the guys denested it off the lasers, they made sure that they had a 4 count. And then every step of the way is going to be quality check. So everyone checks everyone else's work.
Okay.
So you check the guy before you, and then you set it up for success for the guy ahead.
Okay.
So, all right, so next step, like after everything's been deburred and countersunk and whatever, one of our stops is powder coating. So all of these are ready to get prepped for our powder coating operation. So like this part, it's been bent. It has hardware inserted to it, which I'll show you in a second. And then it's been sandblasted so that we can have really good adhesion for the powder. So this is all powder prep. Then everything gets hung in preparation for powder. So these are all ready to be sprayed. Martin, how are you? So then Martin has them hung. He'll spray it with the right powder coat color, you know, whatever color the customer needs. It gets shot. It looks like he's doing a little touch up.
And this is, powder coating is just it's like whatever color they want, or it's not just aesthetic, is it? I mean, it's...
No, it's a protective.
Yeah.
Too. So it's basically a plastic powder. And when you heat it up in this oven, then it becomes like a plastic coating, basically. So it's industrial paints, just made easy to apply.
And was this what you're telling me? Like, if I wanted to do something like this in California, this would be a huge pain in the ass?
It's easier if you started it in the 80s.
Yeah.
If you're going to start one now, yeah, it's possible. You can start a powder coating company, but they're very concerned about your air emissions. Like, we filter everything, we use HEPA, everything's great. But even if you prove that, you're like, hey, we're doing HEPA or whatever, they just say, no, you're using an aerosol. Like, we don't like that. You have to go and fight and argue.
And because you guys have so many customers in California, you would actually like to have a factory there.
Yeah.
This just makes shipping and everything faster.
Yeah, if I could be in LA, that means like order your part by noon, maybe you get it by 5.
Yeah.
You know, especially if we run our own trucks or whatever. It's a challenging environment for a lot of reasons. The legalities around HR are interesting. Air, water, electricity, just the way that they do leases is weirdly weird. Zoning is exceedingly complex, so it's hard. So after everything gets coated, then it goes in the big oven and it cooks for a little while. Then it comes out like this. This is probably, it's a little warm. So this is wrinkle black. So it has this like wrinkle texture comes up out of the oven.
Since you guys are mostly doing cutting, bending, what's the longest part that it takes you? I mean, somebody would have to be doing a really large piece, or?
Powder coating is probably the longest. It has a dwell time of 20 minutes or so in the oven. And there's some prep to it, so it probably takes a while, but honestly, when we run those noon totes through the process, it's like, hey, bend this. And it's a minute and a half of bending. And then it's, hey, countersink this, and it's 30 seconds. So the cumulative time is still maybe 30 minutes total. But because of, capacity constraints, we have orders ahead and orders behind. So we have to be mindful. Like, I don't want to run so many noon orders that everyone else suffers behind that. So it's a delicate balance.
And you're looking for 90% efficiency overall?
Yeah, at least on the laser.
On the laser.
It depends on the workflow or whatever, but usually a lot of our stations are actually above that.
I mean, if you can tell me, like, what's break-even utilization?
Oh, a lot of smaller shops, mom and pop shops are really happy if they get 50 or 60.
50 or 60, okay. Okay.
And then our Armada sales guy, shout out to Ryan Stanich, he's always trying to get us to buy the Armada automation that loads the sheets automatically for us. And early on, he was like, dude, you buy this extra $1 million worth of stuff, it's going to get you up to 77% efficiency. And I showed him our numbers, off his equipment. I was like, dude, we're at 86 right now. He's like, oh. I was like, just use dudes.
Use dudes. I do see dudettes around.
Yeah, dudettes. We have dudettes. This is all staging for CNC bending. So the operator gets instructions from our app to say, all right, here's the part, here's the tonnage required, here's your tooling setup, here's the order of operations. So they'll set up all their tooling. It's automatically programmed into the machine, and then they basically just follow the steps on the screen. For a job like this, after you do a few, you don't need to watch the screen anymore. Memorize it.
For you created like all these training animations and everything?
Yeah, so we duplicated it because in order to become equipment agnostic, like for us to use any vendor, every vendor has their own specific software and their own specific stack. And we didn't like that because we didn't want to get tied into one ecosystem. So what we end up doing is kind of looking at how the machine operates and then duplicating a lot of that. And then it's basically like, do they match? Because here's what we came up with on our app. Look at the equipment's app, or at their screen. If it matches, then we're good to go.
Okay.
So we're basically designing it and doing the DFM and then the manufacturing instructions in our app, sending that code to the machine, and then we're seeing if the machine is like, yep, that matches, then everything's good.
Okay, and so this is a whole host of just shaping the metal.
Lots of little brackets.
And you just gotta get right spot, right pressure.
But after millions and millions of parts, we get really good at understanding what those vectors are, what the distances are, what the stretch is going to be, if it's going to crack or not. And then we take that data and we feed it back into our app so that we can tell the customer, like, hey, careful, this is going to stretch abnormally, this is going to deform, this is going to be weird. So the more jobs that we take in, the smarter we get, the more we
get. Something like this, there's a lot of these. This is a customer that, if they would otherwise have to stamp this out somewhere, or you would never?
Yeah, or a more traditional shop could do this as well.
Yeah.
But a lot of the legacy shops, they don't want a quantity of a couple hundred. They want a quantity of a couple thousand because they're not as efficient at setup. our guys will do more setups in a shift than a lot of legacy shops will do in a month. So like 50 or 60 setups is no problem.
But why are you more efficient at setups?
I guess our software, I mean, we're starting from the very beginning. As soon as you upload, we already know like what tooling it's going to use, how many steps there's going to be, where it fits in the schedule, what machine it needs to go on. Like it's all like a pre-written recipe. Okay. You just have to follow the recipe.
So the more traditional shops just probably didn't ride the whole wave of software and everything that's taken place over the last 50 years. It's like some orders getting passed down on a sheet of paper.
We've seen some shops where they'll have to take this model and redraw it by hand in the equipment software in order for the equipment to handle it. So they have a super manual step. And sometimes they have to do that even for quoting. Like, well, in order to get a quote, I have to redraw it in some like weird CAD system. They're like, okay, I got my quote. And if the customer says yes, then they have to go redraw it in like a different like bending software or something like that.
Yeah.
So we just ripped out all of those steps.
Okay.
This is the machine shop. This is the fastest growing part of SendCutSend. We just made our first part like May 1 of last year. So
What's the difference between a machine shop and what we were looking at before?
so sheet metal guys and machining guys like rarely cross paths. They're two totally different worlds. It's like watercolor versus oil painted or something like that. And I don't know why. Our customers need both. So it's different skills, it's different equipment, it's a little bit different process. So if I had a big enough building, I'd actually put them under one roof. It doesn't really matter, but they have their own building for now. So,
But those were mostly lasers, and this is mostly
lasers
wire, or no?
yeah, so these are 5-axis machines.
Okay.
So they're using a machine tool, which I'll show you here in a second. They're taking a block of metal and then making it into a part-shaped object.
Gotcha. So instead of metal sheets cutting out and bending, this is taking a hunk.
Here, I'll show you. Like these are all tools. All of these tools in here, they're like drill bits, basically. Those are actually hogging the material, out of the machine.
Yeah.
So you can see something get made in here. Yeah, you can look in there. It's a little hard to see over on the side.
Yeah.
Better.
Oh yeah.
So it spins around and, pokes at it for long enough, and then you have a part.
Yeah. And this is the newest part, as you guys are expanding.
Yeah, this is brand new. So here's another look at one of the machine tools. This one's open. So this is part of a cell. So a cell for us is a robot and then 2 machines. The robot's in the middle so that it can just sit there and feed, either machine as needed. So that's probably like the most automation that we're doing. But because this is such a different process, it's a lot easier to automate than on the other side.
But the tools are in the machine, so it's feeding them the raw blocks.
Yes. So it's gonna take a raw block from that drawer, puts it in here. This vise is air, so the vise locks onto the part. The machine does its job. It grabs all of its different tools, and then when it's all done, the robot reaches back in, grabs that finished part, puts it back in the drawer. So the operator is just gonna function from here, basically. I'm not allowed to open this right now, but basically it's kind of magic. It's like Martha Stewart. You pull it out, put blocks in, and then you're like, oh, and here's ones that we prepared earlier, and then there's the
parts come out.
Yeah.
Okay.
Yeah. Is this the one that we're gonna run? Okay. Phil, this is Ash.
Hi. How are you, Nice to meet you.
Phil runs this whole crazy thing. And then he did so good, we gave him a promotion. So now he's actually running all of manufacturing.
Well done, Phil.
Yeah, thanks, man.
You want to show him the steps?
Yeah, you want to go through it?
Yeah, absolutely.
This machine has 32 pallets like this. You call up the pallet that you want. This is pallet 3, I believe. And so you load the material you want. Right now, you go through. We have set torque wrenches with a set torque.
Yeah.
Make sure that we're tight. We essentially place the block in there. We know the orientation of the block. because the paperwork tells us. So you have 3" by 6" by 3".
Yeah, okay.
So you can see, okay, that's how it goes. So we tighten it in there. We'll load it like this. We can tighten it, make sure it's tight. Look and see if there's any gaps. And then close it. And we just say ready. So if you want to press that button, and then just say, leave me alone, go return.
Okay.
And then the robot will come back, put it away, and then it'll be the next thing that goes into the machine. And this is what comes out.
Cool.
So this is the machined finished part.
So is this a full shot? There's a top half to the shot glass, or this is?
No, that's it.
That's it. Yeah. Cool.
Yeah, I think it's double. I don't know. I didn't design it.
Even better, man.
I just make parts. I don't design them.
Yeah. And have you made a shot glass before?
Uh-huh.
Yeah.
Oh, yeah.
You have these at home?
Yeah.
No.
This is very rare.
And we get to keep this?
I think so. I think Jim has a couple of them.
Okay.
Yeah.
Cool. How long have you worked here?
On the 31st, it'll be 1 year.
Okay. And what'd you do before this?
Ran a machine shop
Okay.
in Reno.
How does this compare to?
There are no machine shops like this.
Yeah. Why is it that it's taken off so fast and over these last couple of years, and I just don't have perspective on how this would differ to like a mom and pop shop or somebody else who's really trying to industrialize at scale.
So we're using a lot of really good. So we have a lot of discipline. We have a lot of processes that then enable us to have a lot of freedom.
Yeah.
So, for example, this machine is one machine of many, but all the tools in this machine are the same tools and the same number as every other machine tool that we have here.
Yeah.
They actually have the same configuration. So if we want to run this part on this machine or the other machines that are just like it, there's zero difference.
Yeah.
Not every shop will do that.
Yeah.
So we took the time in the beginning to set up things correctly.
Right.
So I think that's a big thing. Most of the staff around here, in fact, most people that you've seen walking around here have zero experience in machining.
That's what I heard. Yeah. And so you just teach them.
We find good people.
Yeah.
And with good character, I always look for attitude, effort, results. So positive can-do attitude, the effort that goes along with that, and eventually you have to get the results.
Yeah.
So we've all worked with people that are incredibly intelligent, but maybe not the nicest of people, and that's not us. We're just hardworking, full of grit.
Yeah.
And that's how we make things happen.
Yeah. Cool, man.
So,
well, I will drink to that.
Yeah.
Thank you.
Yeah, of course.
Thanks.
We use this like vacuum forming, shrink wrap, foam injection, dunnage, all kinds of crazy stuff.
Yeah.
Because like this, you want to make sure that it doesn't, blow out of the box.
Yeah.
Or rattle around and scratch each other. So we're always trying to like come up with new ways of shipping stuff. Because it's very sad when you had a bunch of guys work really hard and making something, and then it showed up to the customer broken.
Yeah.
And then candy, we get like lots of candy in every
You guys put candy in the orders?
every order. So I'll show you. We go through pallets of Sour Punch straws.
When did that become a thing?
We're just thought it's a nice surprise. I think that like unexpected surprises are the best thing that you can do. So we're like, oh, we'll put a little candy in there. And then customers started saying like, hey, I didn't get my candy. Oh, okay, sorry, like we'll go buy more. And then it turned into this thing where, we're the largest Sour Punch distributor in the state of Nevada.
No way.
We just get, multiple pickups are coming in and out all day. UPS Ground, UPS Express, FedEx Ground, other carriers.
All
Freight.
just straight out here.
Mm-hmm.
Okay.
This is a very, very busy dock. And that's actually one of our constraints. We outgrew this building. You run out of docks, you run out of power, you run out of parking spots, you run out of bathrooms.
Yeah.
There's laws around how many bathrooms per head or whatever. So like, oh crap, we have to go build another set of bathrooms. And it's hard. It's hard to grow.
Just do an outhouse.
Yeah. So that's kind of it for this facility.
Okay.
So raw materials come in, snakes its way through, out the door.
Out the door. Yeah, wild, man. And so how many from this building, I don't know, what's a guess on a normal day, how many parts would come out of here?
Oh, total number of parts? I don't know. Maybe 100,000.
100,000.
Yeah.
Holy shit. Okay.
Yeah, because there's multiple parts in each order. And this facility will do, near 20,000 orders a month.
Yeah.
So,
And if it's running 24/7, do you get calls like in the middle of the night, or things are pretty dialed in?
I used to.
Yeah.
Yeah. But that's why you hire great people.
Yeah.
So we have awesome leads and supervisors on all of our shifts. We have redundancies. We have maintenance around the clock. But yeah, for a little while there, it was wake up 2 a.m. and check the cameras and make sure everyone's alive, and make sure there's no fires. We have literal fires here that we fight. We're making thermite all the time with aluminum oxide and iron oxide.
Shit, right.
So there's just all kinds of weird stuff that we have to worry about. But no, we have a good team.
When did you feel 2018, you guys are building. When did it just go, fuck, this is taking off now?
COVID made it very real.
Yeah.
A lot of guys shut down, and I was like, oh my God, I got payroll to make. Like, we are staying open, and luckily enough, like, we got tasked to make some ventilator parts. We ended up making a bunch of like sneeze guards, or social distancing guards and stuff like that. So we started to get really busy then, and that's when it kind of exploded outside of just the hobbyist region. Like, more companies and bigger brands started using us. So 2021 kind of took off, but we always kind of constrained ourselves a little bit because of capacity. So once we launched our Kentucky facility, we're like, hey, we can actually do more. We can do it faster. We can lower prices. And then, so every time we add a facility, it kind of keeps going up and up.
Yeah. And so Kentucky does all the East Coast, Texas does kind of central Texas and central U.S., and then this is California and then East Coast.
Yeah, up and down the West Coast.
Right. And California is by far the biggest?
Yeah, it goes California, Texas, Florida, New York, and then everywhere else. I don't think we sell a whole lot to North Dakota.
Yeah.
Very few to...
Well, you guys would be some kind of barometer of the health of manufacturing in all these different locations then.
Yeah, we've had analysts call us and they're like, hey, we want to see your data.
Yeah.
I've said no.
Yeah. Have you seen anything over the last couple of years that's a trend or that jumps out at you?
I think reshoring is a real thing. We're seeing a lot of companies say, like, hey, I used to get these manufactured offshore. I tried a few with you guys. The quality was better, the speed was better, and the price was like damn near equal. And I got candy, and I got better support or whatever. So it's happening as people tell their friends that we exist. It keeps snowballing. So I don't know how much of it is like the word of mouth curve versus the reshoring curve.
Yeah. Okay, cool. So when you guys start a new process, you do something kind of funny. You don't really announce it to the world.
Oh, the gaslight launch.
Yeah.
Yes.
Yeah.
That's our world famous technique.
Yeah. How does this happen?
Almost everything we do is an experiment. Like, we have a lot of really good planning. We do in-house testing. We'll open it up to like friends and family and have them beat on it. So we go through some iterations before it gets released to the public. But as our audience has grown, as our email list has grown, we realize that we can't actually announce it all at once. It's like at the Super Bowl, if everyone flushes the toilet at the same time, it causes a problem. So what we do is we just turn on a service and we just wait. And after a few days, people are starting to use it. After a couple weeks, a lot of people are using it, and they're like, oh my God, when did you get X? I'm like, dude, we've had that forever, man. I don't know what you're talking about. Like, you should check out our site more often.
It's so funny because it's like the software industry or something where they don't want to crash a bunch of servers when a new service gets announced. So you can sort of launch it in New Zealand before anybody else knows.
Yeah, there are emails that I could send out right now that would absolutely cripple our network.
Yeah.
So we just have to be quiet. And then
what's the thing people want next the most?
One I'm definitely not going to tell you.
Because you're working on it?
Yeah. I think assembly is something that's kind of interesting for us. So we can make all the parts, but then to put them together, and it's just labor. And I think that's probably one of the things that not a lot of startups are trying to tackle right now, because they're like, oh, it's labor. You know, they're like, oh, we're going to bring textiles back to the U.S. and we're going to highly automate it. And then when you look at everyone else making textiles, it's just a lot of people working sewing machines. It's the same thing with assembly. Like, you just need a lot of people who are doing repetitive motion or whatever. But it makes a lot of sense. And if we can do it, it's a massive value add to our customers. So that's what we're working on now. But that's one of those things that could be absolutely crippling, because it's going to take us a while to scale all the assembly staff and all the infrastructure.
So if all the do-it-yourselfers know about you guys, as if some big chunk of the Fortune 500 already use you, every aerospace company, how do you guys, you already said you want to build more buildings because you guys are at capacity, but like where's the growth coming from? How big can this get if everybody's already turned to you?
What is it? Metal machining and forming or whatever is like 7 trillion. So, you know, it's a massive market globally.
Yeah.
There's little shops in every city in the U.S. and we can complement their capabilities. I don't know how big we can actually go. I look at Home Depot, like just in Reno, there's 3 Home Depots. I don't think we need that many SendCutSends in a, tier 3 city like Reno, but there could be a SendCutSend in, 20 different metros and serve all those customers really, really quickly.
But you get, is there part of you, I mean, part of the story is like, oh, the mom and pop shops are closing, people are retiring. Like when Amazon came and really hit the scene, then it's like, oh, now you're putting mom and pop shops out of business. It's a little different in manufacturing because I feel like people weren't necessarily going to continue on.
We've heard that too, and I think a lot of mom and pop shops realize that we're not a threat. We do the basics at a very, very large scale, but there's so many other little specialties that we're not interested in doing. The market is too small, or it's too complex, or it's too fiddly, or whatever. That's where those mom and pop shops are transitioning. So, for example, like this, our guaranteed tolerance is plus or minus 5 thou. If you measure this is probably closer to 1 thou accuracy. But there's shops, or there's designers that need even better accuracy. They need plus 0 minus, a tenth of a thou or something like that. What we're doing a lot of is we're making these and we're giving them to another machine shop, and they're doing the final operations, or they're doing some sort of weird coating on it, or they're doing the certification or something on it. And so it's still, there's like this good ecosystem that we're supporting. It's almost like you can be a restaurant that's like growing all your own food and you have your own cattle and stuff like that. Or for us, we're like providing them with the raw ingredients, and then they can actually go make the meal.
Yeah. This is stainless steel?
That's aluminum.
Aluminum.
That's 6061 aluminum. Yeah.
Okay. Cool. I get it wrong every time.
Yeah.
I guess aluminum and stainless steel.
You would know stainless is very heavy.
Yeah.
Like my business cards, very heavy.
Stainless.
Yeah.
It's terrible. I got to get better at this. Amazing, man. Thank you so much.
Yeah. Thank you.
Such a
Thanks
cool
for the
thing you
opportunity.
guys are doing.
This is cool.